we're really gonna get this GAN running. We had started the process. I have not run the model since then, actually. I thought maybe I would do some stuff off screen. I didn't do any of that, it turns out. But that's okay. We're still going to have it. We're still going to see what we got. It'll take a little bit of time to catch up. What the heck was I doing? You know, that's always the problem that I have. It's been a week since I've looked at some of this stuff, and I don't always remember. I'm going to remember the auto indent this time, though. 100% going to remember that. Let's rebuild our data, do all that stuff, and then get back to this. Come on, TensorFlow, keep going. I may have updated some of my software, so we'll see if things are just terribly broken as well. Always a risk. I meant to do that over the weekend, but got very busy. Okay, that's all our data. I got my extra, this stuff. Let's do this stuff, sure. Grab all this stuff. Do I just save my data somewhere as umpire arrays? That would have been smart of me. Did I not do that? I don't think I did that. Didn't think I did that. Oh well. End length equals 16. Char indices, all this other nonsense. Okay. It's not as... I feared that there was a ton of stuff here, but there's not actually. I've not saved any kind of model either. So, we gotta make the generator. Like that. Make the encoder, which is gonna like pre-train our generator a little bit. You don't have to do that, but I think it's a good idea. And you make a model from that. Together. Cool. Make that model right there. How long is that gonna take? Hopefully not too long. Cool. Okay, while that's training, make sure I understand whatever the heck else I'm doing here. That trains the model. Then we were gonna see convert a string here to the format that the model expects. That kind of, not one-hot because it's sparse categorical cross entropy. And then do some predictions. So you put in foo-wire labs, what do you get out? That kind of thing. Okay, great. Then you generate some possible names here, it looks like. Oh yeah, that's where you get the actual names. Convert it back into a string. Okay, great. We need to convert it to one-hot to use in this other model, because that's what it's going to handle. And this is our discriminator, which takes as input the stuff that comes out of the generator or an actual image, either one of those things. Okay, cool. The discriminator just gets created alone, and then we create what's the GAN, the generative adversarial network, the generative part, the adversarial part. That's just the generator and then a discriminator, and that gets compiled as well. We're going to make some fake data. Right, this is what I needed to fix. Right now, I'm sampling from the entire space, which is wrong. Yes, I sample from the entire space. I want to sample instead from the space that is actually created. Okay, this is what we need to fix. Instead, sample from relevant space. From a similar space to that created. So we'll need to figure out how to get that similar space. So we want to run our training data through the autoencoder. So where is the autoencoder? That is model. Okay, cool. So we take the first 0.9, I think. Right, model.fit. And then we do validation split. Let's see. Yep. Data, which to validate. Validation split. Nothing. Great. I assume it's the last. It takes the last 10%. I don't think it does anything smart and swaps things around, which is fine. It's totally fine. I do want to see how does this model actually do. Out names. There we go. Yeah, not a lot of interesting things there because there's so many new lines. That's okay. We're just trying to see, does this actually, do anything? Make the discriminator. Make the GAN. Okay. Then we need to make the fake data. So what we need to do is take our model. And we need to call model.predict on our input training data. What did we actually train on here? Sparse data.reshape, whatever this nonsense is. What is this? And the output, oh, it's an autoencode, right? So the output is sparse data. Hey, you know. What is this? There's that many things that are 16 long, and there's one channel. I assume I had a good reason for doing that, but whatever. Let's take this stuff. In data, we'll call this that. And I want in data, my training data, to just equal in data up to, I don't know, int 0.9 times length of in data. There we go. Grab that, grab this. This is our training data now. Cool. And we are going to run our predictions on this. This is just, no, I don't want to run this on the model. I want to run it on just the encoder part. Right. And actually, what is the encoder has the same thing as its input. And like times 1. Cool, cool, cool. So, we want our, like, what is it? Latent or intermediate, the hidden layers, latent space, I guess you could say. That is going to be encoder.predict. And it should just run it on T-data. Let's see how this goes. Might take a little bit of time. That is most of the data. Cool. Latent. Now we got a bunch of numbers. These are sort of the types of numbers that you will tend to see. Like a lot of zeros. Those zeros, actually that is a lot of zeros. Plot dot p color mesh of latent. Give me everything and everything in the first one. Let's see what that gives us here. I fear there are just a lot of zeros. There are a lot of zeros. That is curious, actually. That's that is so regular. That's weird. That's really weird. Like, I expect the output distribution to be, you know, approximately equal across all of them. Here's something we can look at, though. Let's take the mean down that axis. Number.mean of latent, comma, axis equals 1. And actually, what I want to do, I want to get rid of that last channel. That's driving me nuts. I don't. I thought I did, I don't. Because I'm going to need that channel for input into my other stuff. Dot reshape of -1, comma 16, comma 256. That's how many things I have. That's right. Yes. There we go. And now these are all your various numbers. What we're going to do is do plot dot. Oh, let's just do plot dot plot actually. Don't think I want a heat map. Oh, okay, maybe I do want a heat map. Nope. That was not what I wanted. X is 0. Not across the thing. Yeah, there we go. So you see there's a lot of cyclo behavior, periodic behavior here, to where it's like the same thing repeated 16 times. Not too suspicious given that we have 16 inputs and most of them are 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Who bought it? Yeah, very similar. I wonder if that's due to the like convolutional nature of this input too. Is it not spread out enough, or the way it's encoding? Something we might consider taking a look at. Or maybe, you know, we don't need 256 numbers. Maybe we could get away with 16 numbers and see what happens. You're supposed to compress the space. We haven't really done that. We've expanded the space quite a bit. So actually, that is an interesting point that I will think about later. Not right now, though. Yeah, 256. How did I... Oh, because I'm 1D transpose. We're embiggening. Yeah. That's an interesting point. Okay, well, it is what it is. Point being, we want to sample from this space something that looks like this, you know. And I bet if we do, instead of that, a heat map. Oh boy, oh boy, oh boy. P-color mesh. Can I get away with this? No. No, because you'd have to reshape it. Because it's not smart enough to handle. Reshape into 256, 1. Yeah. Doink. Yeah, and then you get this sweet rainbow effect of the same thing, right? Increasing this way, of course. So that's kind of slick. And actually, I think this would look ever so slightly better. In that direction? Yeah, there we go. So you see most of these are basically 0. Or 1/2, excuse me. Some of these ones, actually they're all almost 1/2. Some of these are 1/3. Over here, they're all generally a little bit, okay. They're not exactly the same, but they're pretty dang close as you go up and down those. Point being, that's the distribution we want to sample from. So what I'm actually going to do is I'm going to make a histogram of each position. Not histogram. Actually, can I histogram? Can I do this? Let's see. Just compute it over to flattened array. What I really want to do, I don't really want histogram 2D, right? I just want, 20,000 or whatever. Not 20,000. I want 256 histograms is what I want. Because otherwise I need a 256 dimensional histogram, and that's not really what I want. Okay, so distributions. Make this an empty. No, I know what its size is going to be. NumPy.zeros. There's going to be 256 of them, right? No, 256, comma 10. Right? How many bins do I want? I'm going to say, give me 10 bins. That's fine. I think that'll be okay. Or I just get the mean and standard deviation of each one and do a normal distribution. Let's do that, actually. That'll be, I think, a little bit easier. If I just get all my means, I mean, the data is not actually normally distributed along each column anyway, but we can pretend, because you can do histogram along a particular column. So latent of all of them, comma, I don't know, 15, comma 0. One of the ones that's interesting anyway, right? This one, reasonably interesting actually. Mostly small, but a few large values. You could plot, well, actually I could do plot.hist, can't I? I don't even need to call NumPy here. Ding. You get something that's not at all normal though, right? Look at this. That's super not normal. Oh boy. Oh boy, oh boy. Alright, 14, that's a little more normal. Ish. More like a chi-square distribution, I think. Being the sum of a whole bunch of things from higher up in the network. That tends to be what you get. Okay, but that's close enough. So we'll take numpy.mean of our latent space dot reshape. Yeah, we'll reshape it for now. Maybe I don't need to do that though. No, I don't think I have to do that. I can just do this over the 0 axis. Yeah, and then I get the shapes that I want in the out. Ding. So a lot of these are essentially 0. This is 2? What? That's wild. That one's almost 0. I did not think that was the case. Did I not, look at this right? Oh, yeah, oh, okay. That one is indeed 2.5 or so. Huh, what do you know? Okay, well, that's cool. Do that, and then do the same thing for the standard deviation. Which I think you can just do this. Boom, so good. Look at that. Now we have a whole bunch of standard deviations. Like some of these never change at all, which could kill us at some point. If standard deviation is 0, we'll just always report the same value. Essentially, those are never getting used because they're not reporting anything interesting. They're never changing. So just use whatever the mean value is. Just use that. Okay, numpy.random dot normal. There we go. Draw random samples from normal Gaussian distribution with this location and this scale parameter. Right. So if I said, you know, does that work? Yeah, okay. And this should always give me 1. Cool. So what we're going to do, those are our various columns. I don't need this big or whatever other nonsense. I don't need fake data this way anymore. I'm going to make it down here. Yeah, there we go. Oh yeah, that's what I'm doing here. Okay, to make our fake data then, what I want is numpy.random.normal of m comma s, so whatever our current mu and our current standard deviation is, or estimate for it. And I want size to equal, what is this? Length sparse data. Yeah, sure. I'm making as much of that as I was before. I think that's right. But what we're going to do is this. Do a list comprehension for m comma s in zip mu comma standard, because I don't think I can vectorize this quite the way I want. And we can d-type that I need, d-type numpy float 32. Yeah, sure. Numpy.float 32 right here, float 32. So I think that'll do what I want. I don't need this, I don't need this. Yes, the fake output is all zeros. These are all, you know, wrong. They're not real, I should say. See if I go there. Boom! So now we have data that should have approximately the same distribution. Axis equals 0. Plot dot plot. Show me something good. That is nope. Fake data dot shape. Okay, I gotta see what I need to do here. Dot transpose. Doink. Yes, and now you see the same kind of behavior because we've generated it in that way. Cool. Sparse data dot shape. What is this shape of this? Who's it? What's it? Comma 16. All right. Well, that's fine. So what is our one hot data? It needs to look like the same shape, right? Yeah, one hot data dot shape. That is the actual correct data. Again, takes the, takes the generator, the encoder input, which that needs to have this extra 1. So, fake data reshape. Isn't there there's a way to just add like an empty dimension in NumPy. Add empty, yeah, empty dimension. Okay. Expand dims. That's what I wanted. Latest documentation. Look at this. Okay. Well, buddy, if you don't look to the same page, then what are you gonna do? Certain axes appear at the axis position in the expanded ray slope. Cool. So if I said numpy.expand dims of fake data, comma, I don't know, 2. Can I do that? Dot shape. Yeah, there we go. Okay, cool, cool. So I don't have to do reshape. I make it a little more explicit what we're doing here, which I like. Even though you could just reshape, it's the exact same thing. think that's what we want, because I think that's what the GAN is going to take. Let's see if I can do this actually. It doesn't say what the input shape is. It says what the output shape is. Encoder dot. No. Yes. Encoder dot summary maybe will tell us. Can you interrogate an input shape? Input shape. Input shape. Whatever, comma 16, comma 1. Oh no, I don't want the encoder. I want the generator. Right. None, comma 256, comma 1, and of course our fake data has the appropriate shape. Whatever this is, comma 256, comma 1. Okay, cool, cool, cool. And it's stuff that's in the right format, so we should be able to run this now. Look at that, ahead of schedule. And watch this blow up my face. Fake out is not defined. So I get for not running that one. So obviously, yes, these are all false. They're not what we're looking for. True out has not been defined apparently. Where's true out? True out. Oh, it gets defined in there. I don't really need to define that every time. Really, we can define that right there. Yeah. So we're going to train with the GAN for a bit, and then train with a discriminator for a bit. The GAN for a bit, the discriminator for a bit. If we wanted to do this correctly, you would sort of randomly pick, maybe with each batch, or with each sample, what you're actually going to do. So, you know, it's accuracy, 60%. So 60% of the time, the model is able to figure out, hang on, that was not the kind of thing I was expecting. Or like that is false. It really just needs to learn, it's always false here, it's always true here, but it doesn't have the sense to do that. And it seems all our accuracy, okay, there we go. Seems to be constantly vacillating between one and the other, right? Well, that's perfect, and then it always starts 0, and then picks up. Gets about here? Yeah. Is it getting better and better, though? Yeah, what I need to do, I need to, like, add some information here. Print. Train GAN. And here we have print, you know, train discrim. Like, the discriminator gets trained during both, right? But the generator only gets trained during this section. Somehow it always reaches 100% accuracy on theirs. But it like stays crummy on here. The validation, what's the validation accuracy? That's the real question. 1. That's super suspicious. It is improving, maybe? Question mark? Has it figured it out finally? I don't recall how many we've done here. Okay, I think it's figured it out. Maybe my data is too fake. But then you can look at the generator and start to see, okay, how good is the generator? And so we'll run back, grab some of our generation code, over here, this stuff. Things like this anyway. Test generator. So what kind of startup names does it generate? That's the thing that we care about the most. We finished off on the discriminator, which is fine. So we don't actually need to make data this way. What we need to do is generate like some more fake data, right? Like the last, we can just look at the last one. Fake data -1, right? Because it never got to see this. This was only ever a validation entry. So we should take that and plug that into the generator and see what we get. So here's what I want to do. I want to take, not model.predict, generator.predict. And it's fake data of -1. What I want to do is -1 to the end, so it's the right shape. Okay, cool. So now we have some predictions here. What are these predictions? These should be 16 letters. 16 not one-hot encoded things, but we ought to be able to take this, just run this directly. A whole bunch of R's. Interesting. Interesting. Yeah, I'll tell you what. Let me take like -1,000, -10 here. Do I always get all R's? Always get all R's. Interesting. So I suspect the generator has gotten itself into a hole where it will always generate the same hot garbage of all R's. Actually, let me take the first 10 then. Print out names. All R's. I don't even need to print them, actually. Everything is always an R, right? I have a crazy idea. I'm going to run the prediction on everything. Do this. Take, a little bit of time, like a couple seconds. And then we are going to create a set of out names. I see. So we see the model's not doing a very good job here. It has only learned to say, like, it's a whole ton of R's. And there's a couple slight variations in the types of R's that you can create. But it's not very good. So now we get to the, really frustrating part of machine learning. I have a model all set up in the framework. I got to tweak this, tweak that, do this other thing. What I think we really want to do, one, our encoder is hot garbage, right? So something we can do, I think is an interesting idea, is rebuild the generator from scratch. Just rebuild that. And rebuild the discriminator. And not pre-train it. And just see what happens. I am honestly kind of curious. Like, is it going to be just as bad? I mean, clearly it said it learned to just compute how many R's are there. Okay, great. And the GAN then, or maybe I've screwed up my GAN. That is also another very, very real possibility that I'm not, my generator is not getting proper credit when it fools the network. And in fact, I think that's actually correct. Yeah, okay. Because right now the generator, it's incentivized for this to be correct. When it is correct, I think about this the right way. Hang on. When the generator is correct, when the discriminator is correct, the generator should get punished. We should move in the opposite direction. When its loss function sort of needs to be the opposite or the inverse of the other's loss function. Right now, like, they're sort of co-aligned, which is not what I want at all. Interesting. Interesting. So I think whoa, what's going on? I think I may have screwed this up a little bit. Let's look at, yes, this deep convolutional generative adversarial network, which is pretty much what we're doing. Generator, discriminator, real world images, sure. Yeah. So we're not doing a great job yet. So let's see how we can fix this up. Create the models, create the generator. Blah, blah, blah. You take in a bunch of stuff. Here you're just generating the data. Output something of the shape that you want. Great. Should generate a bunch of random garbage. It's fine. Totally fine. Discriminator takes in an object of interest, this thing, and spits out yes, no. Cool. Make discriminator model. Oh, that's just this thing. Discriminator, generated image, decision. Cool. Define the losses and optimizers. Cross entropy is this. The discriminator loss. Oh, okay. Hang on. Real output, fake output. Generator loss. What? This qualifies how it was able to trick the discriminator. Intuitively, if the generator is performing well, the discriminator will classify fake images as real. However, we will compare the discriminator's decisions on generated images to an array of ones. Yeah. So you see how this is ones like, and this is zeros like? So this is where we screwed up here. the loss function on my network needs to be a little bit more complicated when I go to create it. So, what do? Where do I define the GAN? Like the compile. I need a special loss function. That is the problem. So, you know, we're not done. We'll see if we finish this week at all. Scan loss function. I mean, maybe I don't want to give a loss function for this at all, because I already have one here. Do I have a loss function for the generator, though? Sparse categorical cross entropy? What? Is that because we're using it in the encoder? So like that might be, you know, wrong. It's not really what we want. We wanted to get credit on whether it fools things or not. Generator. Is there a loss? Yeah, okay, so there's some things we gotta fix up. Can by example, this other stuff. Let's see if we can do this live on the show. Oh, this is a terrible set of code. No syntax highlighting? Keras code for discriminator, great. And then you're that, again, your discriminator. Yeah, that's normal. Your adversarial model, though. It's AM, self-that-generator, self-that-discriminator. I don't think this is, like, this is what I have now. But I don't think this is correct. Clip value, all this other stuff. Because the generator, he never compiled separate. Generator is this one. There's no compilation here. Trouble. Generator. This will only train your discriminator. It'll train your generator to make things easy for your discriminator, which is the opposite of what you want. Yeah, show me your complete code, because I'm suspicious here. Deep convolutional GAN. That's what we want. Yeah, I am a bit suspicious. Loss. Binary cross entropy, you claim, for the whole thing. And it's just the generator, the discriminator. Self.generator. What is self? Which returns this new model, which has itself no loss. Right, because if it's trying to help the network, that's not really what I want to do. I want the network to, you know, be challenged. So, yeah, it's like I want to think about this a little bit harder. The loss of each of these is very, very different. And I don't think this does the thing that he thought it did. At least it doesn't really look like that. So I may have to think about this off air a little bit. Implement the GAN training algorithm. Sample mini batch of M noise sample, mini batch of M examples. Data generating distribution. Oh, yeah. Take your noise. Sure. Update the discriminator by sending its stochastic gradient. Okay. Sample mini batch of M noise samples. Sure, from your noise prior. That's what we're doing, yeah. Update the generator by descending its stochastic gradient. Well, you gotta recompute that, Val. For k steps. You update the discriminator k times, and then you update the generator once? Why? That to me is very strange. Also, you need to run your discriminator on this. So you just, hang on. Yeah, I shouldn't have one GAN model. I think that's part of what I'm learning here. Despite what they have there, I don't think that's correct. What I need to do, this is getting a little bit goofy. I need to have like frozen weights for the discriminator when I apply it with the generator to determine what credit does the generator get. This is actually, like, I don't see how this code is working. Train on batch. He's doing one batch at a time, which is fine. Adversarial train on batch. I'm actually curious now. Like, does this code actually work? I am inclined to try it. Let me select all. Make a new thing here. MNIST deconvolutional GAN.py. You know, I want to know, does this actually work? Oh boy. And Vim is shit in a brick. Come on. Hey, no, just stop. Just stop. Set, paste, get this in here. There we go. Okay. Yeah, sure. Is there like an epics thing in here somewhere? Train steps. No, you will absolutely not be training that much. Ooh, come on. Like 100 or something. I don't know. That's fine. Percent run, MNIST. Yeah, that's fine. No module named this thing. Why am I not surprised? Examples.tutorials. tf.examples. What things do we have? What tab completion? No? Is that not a thing? That's a thing. What do we have? Nothing, of course. Of course, of course. Alright, well maybe there's some more code in here. Generator predict. This is like pure NumPy, isn't it? Holy moly. Almost. Generate points in latent space. Generate fake images. Generate more fake images. Update weights of the discriminator model. Classify real update weights of the generator. Okay, okay. So in my loop, I really should just generate more data. Dot. Yeah, that's cute. So let's train these standards. Too many. One coming from the data set. Okay. Yeah. There's some other specific things that I'm not too concerned about. Train GAN models in practice. Train on batch. Train on batch. Fake. Real. Yeah, sure. Oh, okay. Here, that's the catch. But hang on. Generator, discriminator, sequential, create it. It's still binary cross entropy, but this is trainable false. But like, I want to fool the discriminator. I want the discriminator to be wrong. So it's like I want the opposite of binary cross entropy. That's what I'm thinking is like screwed up here. Okay, but this is the catch that I needed. No, stop it. What is going on? Nonsense code. Copy. Oh my god, just bring, horrendous. It's the website trying too hard. Okay, so let's go back to our, screw that. That thing's done. We're gonna fix this ourselves. We have a discriminator, right? We have the GAN part. So I think maybe we do want that function, right? Get GAN. Get over here. Def get GAN, the generator, and the discriminator. And I don't have set no paste. I don't know why paste screws up my auto indent like that. I feel like if I'm not pasting, it shouldn't be the problem. Model equals was tf.keras.sequential. Where is it? Just sequential. Okay, back to this. Should be pretty much exactly this. Yeah, let's just use the same name so don't go nuts. Discriminator. That's fine. We need to say, set that to false, yeah. Discriminator. Say discriminator.trainable equals false. So right now, discriminator is this. Oh, it's just discrim, isn't it? Because I'm crazy. Yep, discrim. Perfect. Come over here, actually, excuse me. Discrim. Discrim.trainable. And if I say equals false, we get this. Okay. Okay. But in return the GAN, right? Yeah. I think that's correct. But complete our tour of the GAN training algorithm. Like, I still don't think this loss is right. It's like, you want credit, you need credit when the answer is wrong. That's the thing here. So it's like, I need to invert all of the outputs here. And then I'm happy about the answer I get. So I need to just like add a single layer. It's just like, oh, just show me 1 minus that, right? That's what I want. I'm trying to think of how to make that happen in Keras layers. Like Keras simple, or like it's a custom loss function, you know. 1 minus x. In fact, I don't want the word simple in there. That's not informative. Core layers. Layer I want is 1 minus x. How do I do this? Like, you have a bias of 1, you have weight set to -1. That is one way to force this to happen. Normalization noise, layer wrappers. Activation equals linear initializer. Oh my gosh. Like, this shouldn't be this complicated here. This is one thing that, like, in TensorFlow was actually a little bit easier, because I would just be wherever I was in TensorFlow, and I would just say, you know what, yeah, take this thing, 1 minus this thing, and we're done. But in Keras, it gets a little bit goofier, because you have to make it fit into this layer construct. That's not what I want. Writing your own Keras layers, and again, we don't really want this to be that complicated. Oh gosh. Yeah, we really don't. We really don't. Oh my gosh. All of this stuff is like, you don't want to do it. A custom loss function. Yeah, that's probably what I want instead. Again, we don't want complex ones. It's a very simple thing. Okay, that's probably close to what we want. Doink. Or close to the right idea anyway. Again, I'm not sure how those other things claim to be correct. Not. Do I have K? Do I have backend? I have TF though, right? TF.sum exists? No. What? Does that not exist? Ugh. What a drag. TF.keras.backend.sum? Okay. Sure, that's fine. Anyway. Binary cross entropy. Backend functions. No, that's not what I want. I want, you know, binary cross entropy Keras. Yes. How do I like get the function that gives me that? Because I essentially just want 1 minus this. Or, I can make it, no, I don't want to make everything native. It's like, a simple layer would do what I want to do here, but I don't want to get that involved. Keras layer, I don't know, calculation, fixed? Something, fixed weights. A Keras lambda layer, that's maybe what I want. Stateless customers, lambda. Simple stateless customers, you're probably better off using layers.core.lambda. Okay, sure. Where's layers.core.lambda? Layer, core layers. Lambda, not on this page. Don't tell me it's a core layer and then not have it on the core layers page. Keras core layer lambda. There we go. That's what I want. Function. Apply this arbitrary TensorFlow function. That is what we wanted. Okay. So what we add here is gan.add tf.keras.lambda .layers .lambda capital L, right? Yeah, okay. And I will even do like a stupid function here. Lambda. Do they have an example here? Okay, they did. Yeah, that's one way to do it. Lambda x. Lambda x, 1 minus x. This is all I wanted. Okay, this should do what we want then. Now the generator gets credit when the discriminator is wrong. That's the thing we're interested in. Ugh, it did not need to be that complicated. What a hot mess. Okay, we grab this. Doink, go down here. That's great, sure. I want to discrim.trainable. Need that to be true for now. Like here, oh gosh, I don't even know which one of these it was anymore. Over here? No, none of these? I don't know where it's gone. One of these that had trainable true, trainable false, that gets set in here. But I think that's going to affect our original object. So if I say, I don't know, g equals getGan, generator and discrim. Sure. This is probably trainable. Great. But this is no longer trainable. Great, you know. Yeah, super bad. So, what I think we actually, it sounds a little crazy. This, when we make changes to this, we'll change the discriminator. So I think I need to get a new GAN every time. Or I just need to set, hang on. Discrim.trainable equals true. And here we say discrim.trainable equals false. I think this will do what we want. And obviously, yes, you're supposed to do little mini batches, and we're not doing that. Certain things we will accept. GAN equals getGAN. Generator, discrim. Actually, let me make new. Well, no, I already made. I'm pretty sure I made new. Pretty sure that's what I did. We'll find out in a second here. We set that to false. We train that. We set it to true. Hang on. Hang on a second. Hang on a second. We set it to false. And our goal is just to fool the discriminator. Right. Then we set it to true. Okay, what we need to do here is also do the fake data here, right? Fake data. And fake out. Obviously. There we go. That should be what we want. Okay. Let's see how that goes. See if this does something approximately like what we want. The accuracy should start, you know, hot garbage. That's fine. I hope it goes somewhere. No? No? Nowhere? Nowhere. Accuracy 1. It's, you know, fixed. Error checking input. Expect input 5 to have shapes. You've got to input. Whoa, what? Oh, right. Not that. Instead, What we want is, what is fake out? Fake out is the, yeah, okay. Gen data equals generator.predict of fake data. And then this goes here. If I could, you know, type correctly. Let's do that. Let's give this a whirl. Again, that's slightly disheartening that, there it goes, okay. Obviously, it just needs to learn, all right, somehow I need to fake this every time. I mean, discriminator is not very good. It thinks it's very good, but it's going to learn very quickly that it's not. Yeah, look at that. Not so hot now, Mr. Hotshot. Okay, I think this is doing the correct thing now. Things may get stuck in corners of various sorts. And again, we're not doing the mini batch training. We could do that though, right? We could say for mini batch in range. Oh gosh, I don't know how many. We're doing batch size, what, 256 here? 32. I think they're all 32. This is improving actually. Generator's starting to fool things. So I like that. Oh no, the generator's not making any progress. I see. And the discriminator is crushing on the real data. And doing terrible. Yeah, okay, no, it's learning something on that. Yeah, that is disturbing to me. That is not what it should be. I don't know why it's always 0 accuracy there. That's very strange. So we're training a decent discriminator perhaps, but the generator just can't make any progress. I feel like the generator has the harder job here, though. For mini batch in range, I don't know. Length of, what do we got here? One hot data. Sure. Divided by 32. BS, the batch size, equals 32. Just going to decide that right now. Do this like that. Yeah, if the generator could start doing something, I would feel a lot better about this, but it's just not doing anything, it seems. It seems perpetually stuck, which is bad. Real bad. Which batch are we on? We are on batch. Oh gosh, I don't want. I just want to call this M. We're on batch M's times BS to up to M plus 1 times BS. Right? Yeah. In fact, what I think I'm going to do is say start equals N times BS. Stop equals M plus 1 times BS. Because we're going to be using that over and over and over again. Start. Stop. Start. Stop. Stop. Just like that. So I'll just grab this and do this everywhere. Generate that fake data, do this, do that, do the other thing. Yeah, that didn't get anywhere, which is distressing. Alright, does this do the right thing? Same number of samples, he's found 0 input samples and 32 target samples. Why are there 0 input samples here? M, start, stop. Fake data, start to stop. What's the problem? Fake out, start to stop. Yeah, so we gotta figure out what is going on here. That this is all a little jacked up. On validate and 4 samples, it's great. You didn't like your. I just can't see what line I'm actually on. It's one of the lines of fake outs that are down here. Training discriminator. We got through this one, so down here is unhappy. Oh, I see. Gen data has everything because we did it correctly up there. I see. Doink. That should be good. Obviously, like, this is useless to me to see now. The vast majority of the time is just spent printing nonsense. Yeah. So that's going. I see some numbers. I see a lot of zeros, though. I suspect the generator is still showing a bunch of hot garbage. To scroll up here. Yeah, generator always 0, it seems. Tell you what, let's reinitialize the generator. And then see what if we can fix this up a little bit. Let's reinitialize the discriminator while we're in neighborhood 2. Doink. And the generator. Yeah. I'm not gonna give him any kind of compilation there. That's dumb. I don't think I want that. Don't know why I would do that. Okay. Get a new GAN. Cool. And then we train. This is going to be super messy. But there it goes. Is this... I wonder, are these other people's examples? Now I'm curious, actually. Like, is this super just not that noisy? I mean, they generate new random data on the fly, which I could do, I guess. I suppose I could do that, too. Do this, something like this. Come down here. Make what the heck? That's not what I asked for. Come back up here. Grab that. Okay. I can make new data right here. Except, what do I want to do? Size is not like start data. Size now becomes length of, not length, just size just becomes BS. Yeah, there we go. Then you expand it. That's great. And then you don't need start stop on it. Just use it. Directly, like. And then you're generating new fake data all the time. Yeah, this is hot garbage there. Absolutely horrendous. What is this nonsense? Oh, that's part of this. Like, let's do that. Okay, we'll let that roll. All right, I think that's probably going to be as far as we get tonight. I'm not sure about these zeros. Might be a limitation on the model. Might be something else. Something to investigate. Might be some finickiness. But now at least think we have the correct losses in place to where our discriminator, it trains on stuff generated by the generator. Hey, what do you know? And the generator, we freeze the discriminator, and we see how the generator does. Is it able to fool it? And we want the generator to be wrong. We want it to be wrong for the generator's purpose. So that's why we have this extra layer in our GAN. I don't know why that's not in any of this other stuff. That's driving me a bit bonkers. These are super long lines here, pal. Adversarial model. Generator, discriminator. Like, they don't have anything fancy there. Discriminator. Self.discriminator right there. Or maybe the learning rate is too terrible, or there's a lot of reasons why this might be doing very poorly, so to speak. I don't know why I chose Eta Delta. I don't know. We'll let that go. Okay. Thank you, everyone, for watching, checking out. I think we probably will do another one next week, just to see what the final output is and if I get around to improving the models at all. Hopefully I'll have my internet sorted out, so I won't have quite the same problems that I had this week. But thank you, everyone, for tuning in again. And don't forget, stay safe in the data mines.